Okay, in this video, I will go through question 2 from exercise 10F from mechanics 1. Okay, so the question is quite a long question, so let's read out the question first. Okay. Two particles P and Q have masses of Km and 3m respectively. So we can see here where K is less than 3. Therefore, Km is less than 3m, and as a result, the particle will move in this direction, which I have already drawn the model for that. The particles are connected by a light inextensible string, so therefore there is no friction, okay? And the acceleration at any point of the string is the same. Okay, the system is held at rest with the string taut. The hanging parts of the string vertical and with P and Q at the same height above horizontal plane, as shown in the diagram. The system is released from rest. Okay, so therefore initial velocity is equal to 0. After release, Q descends with acceleration of 1 over 3g. So the acceleration of Q is 1 over 3g meter per second squared in this direction. Therefore, P is moving upward and Q downward. Okay? Calculate the tension in the string as Q descends. Okay. So to do this, first I have drawn the model for the particle. Okay. So this one is Q, which is 3m kg, and this one is km kg, okay, which is P. So obviously it's moving in this direction. Okay, so 3m g Newton. And there is tension here. Similarly, there is tension based on Newton's third law. Okay, and km downward, kmg Newton. Okay, and T upward and another T downward. Okay. So, we've been asked to calculate the tension in the string as Q descends. Okay, to do this, we can write down equation for either P or Q. So I write down equation for Q. Okay, so I just write down tension. Okay. So for Q, okay, I just circle the. Okay, so we're going to apply the Newton's law for this one. All the forces are entering or existing from Q. Okay, so it's moving downward, acceleration is downward, and which is 1/3 of g meter per second. Okay, it would be 3mg minus t is equal to 1/3 of g times by, or mass times acceleration, acceleration times mass, times by 3m. So take t to the other side, simplify this, you should get t equals to 1/3 of g times 3m. 3 and 3 cancels gm. Okay, take to this side, it would be minus mg, which is 2 mg newtons. However, you can substitute g equals to 9.8 and calculate t in terms of m. Okay, so therefore the tension in the string is 2 mg newton, which we don't know what is m at the moment, and we are not required to find answer. So therefore, leave t in terms of m and g. Okay, part B. Show that k is equals to 1.5. To show this, we need to write down Newton's second law of motion for P. So for P, let's see what we've got. We've got tension upward and kmg downward. Since it's accelerating upward, okay, so therefore T is positive here and kmg is negative. Therefore, T minus kmg is equal to mass times by acceleration, km times by 1/3 of g. Let's simplify this a bit further. T minus kmg is equal to 1/3 of kmg. Add kmg to both sides, which you get 4/3 of kmg. We know that T is equals to 2mg. So let's call this one equation 1 and this one equation 2. Okay, so from here we can substitute 2mg for T here. So 2mg is equal to 4/3 of kmg. Divide both sides by mg, you get 2 equals to 4/3 of k. Multiply both sides by 3 and divide by 4, you get k equals to 6/4, which is 3/2 or 1.5. Okay, that is what we needed to. So let's do part C. Okay. So for part C, it says state how you have used the information that the pulley is smooth. So I mentioned this during the time when I was reading out the question. Because the pulley is smooth, okay, there is no friction. Therefore, there is no friction. And if there isn't any friction, what would happen is the acceleration, okay, the magnitude of acceleration for P is equal to magnitude of acceleration for Q. Acceleration of P must be equal to acceleration of Q. I just put the magnitude sign, okay, or modulus sign, because if acceleration downward is 1/3 of g, up for this one would be negative. That is why I put magnitude sign, okay, just to assume both are positive here. Okay, the positive acceleration for both would be equal to 0. Okay. Part D of the question probably is the most difficult one and quite long as well. Okay. So for part D, let's read out the explanation first. After descending for 1.8 seconds, okay, the particle Q reached the plane. It is immediately brought to rest by the impact with the plane. The initial distance between P and the pulley is such that in the subsequent motion, P does not reach the pulley. Okay, show that the greatest height in meters reached by P above the plane is 1.26 G meter. Okay, so to do this, first I need to explain a couple of things here. First of all, Q will move in this direction and P will move in this direction. However, it wouldn't reach to the pulley. Okay, so P will hit the ground. Okay, so first of all, we've got this distance. The greatest height would be this distance plus when Q is moving in this direction and it hits the ground, then P will move the same direction, the same distance upward. Let's say it reached to this point. However, the diagram is not accurate. Okay, so therefore there is distance here. Let's call it S1. Okay, since Q will move up to this point, which is another distance of S1, P will move another distance of S1. Let's say if this one was 1 meter, for example. Okay, so P is already 1 meter above the ground and will also move another 1 meter, which will be 2 meters from the ground. However, after Q hits the ground, what will happen is the string will become slack, so it wouldn't have any impact on particle anymore. But since P has got acceleration at this point, P will still continue moving up to the point when it becomes to the rest. Okay, so this is the point when Q hits the ground, and after this P will continue moving up to this point. So I call this one S1, since this one is S1 as well, because as much as this one is, Q will move that much, and as a result P will move the same distance as well. And after that it will move another distance, let's call S2, this distance. Okay, so therefore the total distance, total height, let's say, rather than distance, of P from the ground or plane should be equal to S1 plus another S1, which is this one, plus S2. Okay, so therefore it would be 2S1 plus S2. Okay, so how we can calculate this? It's a little bit complicated, but if we follow all the steps, so hopefully we will be alright with this. So first of all, up is positive. While Q is descending, the distance traveled by P, okay, so while Q is descending, moving in this direction, accelerating in this direction, the distance traveled by P is equal to S1, as I mentioned this distance, which is the same as this one. So the diagram is not accurate. Okay, so Q will hit the ground. This one is S1 as well. Okay, and obviously P will move the same distance, S1. Okay, so what information we've got? We've got U equal to 0. initial velocity is 0 because it's starting from rest. A is equal to 1/3 of g. However, if you calculate it for p, it would be negative 1.3 g. But we're calculating for q now because that's the same distance, obviously. Okay, so, and the time taken for q to hit the ground is 1.8 seconds. And let's say the distance traveled is, we assume it is s1. Okay, this distance is s1. So therefore, s is equals to ut plus half a t squared. And therefore, s1 is equals to, u is 0, therefore whatever t is, it will make it 0. 0 plus half a t squared, which is equals to 0.54 g, either in meter or centimeter or any unit, okay, which is not given here. That's one. Okay, now we calculated this distance, and we already knew this distance because it is the same as this one. So therefore 2s1 is calculated, which is 2 times 0.54 g. So after this, what will happen? The string will lose its impact on the particle p. It will become slack, and then what would happen is p will keep moving up until it reaches to the speed of 0. However, we need few things here. One, okay, so after this point, I'm writing the information for from this point to this point. S U V A T. We want to calculate S, which is, I call it S2. Initial velocity, which is velocity of particle P at this point, it is the same velocity as Q hits the ground. Okay, so velocity of Q, so initial velocity of P at this point is final velocity of Q when Q hits the plane. Final velocity obviously at this point is going to be 0 because it's going to completely stop. And the acceleration obviously, because the string will lose its impact, there is only one acceleration, which is negative g, because it's moving upward and gravity is downward. And we don't know the time for this, and we really don't need time taken as well. So therefore, we don't really need that. Okay. So we could calculate v of q, which is the same as u of initial velocity of p, by using this formula. V of q when it hits the ground, which is u of p at this specific point, which is equal to u plus at. Okay, so what is initial velocity for at this point? The initial velocity or at this point is equal to 0. So u of p is equal to 0 plus acceleration is 1/3 g times by 1.8, because the time taken from here to here is 1.8, which would be 0.6 g meter per second. Therefore, we've got this one, which is 0.6 g. Okay, now we can calculate this S2, this distance, by using v squared equals to u squared plus 2as. We've got all the information which we need. 0 squared is equal to u squared. The initial velocity of p at this point is the final velocity of q when it hits the ground, which is 0.6 g all squared plus 2 times minus g times by I call s s2. So 0.36 g squared minus 2g s2 equal to 0. 2g s2 is equal to 0.36 g squared. And finally, s2 is equal to 0.36 g squared divided by 2g, which we need to work out in terms of g, which is 0.18 g. Meter or centimeter or any other units. Okay, so now the total distance or the highest point of distance of P from the plane would be, so total height, okay, would be equals to S1 plus another S1 plus S2. We know S1 is 0.5 G, 0.54 G, plus another 0.54 G, plus 0.18 G, which will add up to 1.26 G. Okay, end of the question 2, and in next video hopefully we'll go through question 5.